Okay, let's check out the back of these notes. We are given that A is parallel to B. We're looking for our special angle relationships, and based on what's marked for us, looks to me like we're probably going to be using corresponding angles. We are also given that C is parallel to D. Based on these yellow parallels, it looks to me like I have a nice letter Z right here. So it seems that all of these angles are the same, which is convenient since we're being asked to prove that angle 1 is congruent to angle 3. So let's get to this proof. A is parallel to B. That's given. That told us that angle 2 was congruent to angle 3. And a reason here is if two parallel lines are cut by a transversal, then corresponding angles are congruent. Our other given was C is parallel to D. That told me angle 1 had to be congruent to angle 2. Not the same reason. This time it's if parallel lines are cut by a transversal, then alternate interior angles are congruent. And if I link these boxes together, I'm left with angle 1 is congruent to angle 3 by the transitive property. And we're done. All right, number 4. A little bit messier. Let's check this guy out. MP is parallel to BE. We do have two different transversals happening this time. We have a transversal here, and we also have a transversal here. And because we have two transversals, we have a lot of angles available to us. Our second given says that angle 1 is congruent to angle 2. And they're asking us to prove that angle DBA. Now, I'm going to replace that with angle 3, which I can do as long as I put a 3 in the picture, is supplementary to angle ADE, which I'm going to turn into angle 4 because I think it's a little bit easier to read. So we're trying to show that those are supplementary. Where does supplementary even come into play? Well, supplementary comes into play. The place I see it is with this pink transversal. Per that pink transversal, 2 and 4 have to be supplementary. And per the green transversal, 1 and 3 have to be the same. But since 1 is the same as 2, that means 1 has to be supplementary, and 1 is the same as 3. 1, 2, 3 are all the same, which means all 3 of them are supplementary to 4. And we need to get that somehow nicely into a proof. So I'll start with my parallels. MP was parallel to BE. Was given. And from this, I did take a couple of things. One of the things I took was that angle 1 was congruent to angle 3. Our reason here is if parallel lines are cut by a transversal, then alternate interior angles are congruent. We are given that angle 1 is congruent to angle 2. If I pair these, I get that angle 2 is the same as angle 3 by the transitive property. Now, my goal is to get 3 and 4 together. How am I going to make that happen? Well, I need to get 4 into the question at all. And the way we get 4 into this problem is from our parallels, we know that angle 2 and angle 4 are supplementary. Our reason here is if parallel lines are cut by a transversal, then same side interior angles are supplementary. Now you'd think you could just substitute a 3 into there, but in fact neither of these has an equal sign. So before we can do any substitution, we have to turn both of those into equals. So I have to convert this to measure of angle 2 equals measure of angle 3. And my reason is congruent angles are angles with equal measure. And I have to convert this to measure of angle 2 plus measure of angle 4 equals 180. Now that they're both equations with equal signs, now I can substitute. So if I put the equation on the left into the equation on the right, I get measure of angle 3 plus measure of angle 4 equals 180. By substitution, and since they add up to 180, angle 3 and angle 4 are supplementary. And that's what they asked me to prove, so I'm done with this one. Tricky substitutions, but we got it done.